Hello everyone. Today I want to talk about electrical power. So the formula for electrical power is P equals VI times voltage. So P equals voltage times current, and the unit for power is watts. So what happens if we don't have I or voltage? In that case, we'll have to use Ohm's law, because as you know, V equals IR. So let's say we're not given voltage, right? We can see that voltage equals IR. So in that case, we would be able to write P equals IR for the voltage, and then times it by the I over here. And now, from the Ohm's law, we know that I equals V divided by R. So if we don't have I, we're able to say that P equals V squared divided by R. So because over here I equals the current, so it's the same thing. Say we have a circuit, we have a resistor here, a resistor here, and then a resistor right here. So, and then let's say for the resistor here, the R1, like the resistance, equals 4 ohms, then the I equals 2 amps, and we want to know what's power in this, only this resistor. However, from our memory, we know that P equals voltage times I. We have no voltage. However, we know that V equals I times R. So we're able just to write P equals R times I, which would be 2 times 4 and then 2. And the power would be 16 watts in this one resistor. Now let's say for this one, the voltage for this circuit over here equals 12 volts, 12, and the resistance equals 3 ohms. Now this time, we don't have the current. However, that's not a problem because we know that current equals V divided by R. So we're able just to write P equals V squared, because there's two V's, and then divided by R. So that would be 12 squared divided by 3, which will be 48 watts. So our example is a refrigerator draws 2.3 amps of electric current from a 120 voltage AC power supply. The AC doesn't really mean anything, so don't be scared. It just means that the type it has, and AC is the one that goes in both directions, if I'm correct, or it's the one that goes only straight. And our first question, what is the electric power that is being delivered to the refrigerator? And just quickly, in B we have to calculate the total amount of electric energy. I'll just quickly say that electric energy is different from electric power. So electric energy, so energy is measured in joules or kilojoules, which basically means 10 to the power of 3. Power is measured in watts and kilowatts, which again means 10 to the power of 3, just about the kilo, not the actual whole thing. So another important thing is kilowatt hours. It's not unit of power, it's a unit of energy. And so this is for the energy one. And also energy is calculated by, so energy equals power times the time. And for the power, there's another few formulas. So basically, there can be power is work, like done, times divided by the time. But you can also just do like, because E equals the energy, which also equals to like kind of the work done, it equals to, so we can just put E divided by the time. So P equals VI. I know over there we just did like, W divided by time. However, it's different. It's like you'll just get it. So 120 times 2.3 equals. So this is the power. Also, 1 watt is 1 joule per second. So to calculate energy, we need power times time. So it's going to be 2R76, and we're going to divide it by 1,000, so we get kilowatts. So that would be this in kilowatts. And then we're going to do 24 times 30, so because 30 days and 24 hours in a day. And so we get this, and we times it by the this, and then the unit for this will be kilowatts hours, because over here we had the hours, so that gets us this. Now see, now we need to calculate the cost. So, and the cost equals the 198.72 times 0.11, because that's how much it costs per kilowatt. So the answer will be to the decimal places. Be for the 30 days, because over here we calculated it was running 30 days. Bye.